exam style important question, as you see that the circuit where the EMF is 12 volt, and by the way we are assuming here that this is an ideal battery. Okay, why I'm saying it's ideal battery? Because they mentioned here that there is a no resistance, internal resistance, that is negligible. Okay, and that is only negligible in the ideal scenario. Okay, so it means that all the EMF value 12 volt will be distributed to the external resistors. What's the meaning of external resistance? I mean to say the resistance which are connected outside the battery, the variable resistor and the fixed resistance. And you see there, students, that we have connected a voltmeter across the external resistance 6 ohms. Now, what is the job of 6 ohms? It will actually measure the potential difference on this terminal. Ideally, there is no current will flow in the voltmeter. All the current will flow through these two resistors. Okay, so this voltmeter will just measure the potential difference. Okay, now what we are going to do, we are going to change the value of resistance, and then we will see what value we get on the voltmeter, right? So I will explain you this by the two methods. So let's have the first one. So students, actually the alternative one is in which we will apply the Ohm's law, right? And alternative two can be the unique and the new for you, because I'm going to apply the voltage Devian rule. Okay, so in the first circuit, as you see that, okay, in the question they say that the resistance is in changing from 4 ohms to 0 ohm. Okay, and basically we are decreasing the voltage, sorry, we are decreasing the resistance. So this is a resistance which is fixed resistance 6 ohms, and let's say when the resistance is maximum, okay, which is 4 ohm, so what will be the reading of the voltmeter? How can you know that? So if you find the equivalent resistance first, okay, because I said we will solve it with the help of Ohm's law. So that is the sum of these two. So 6 plus 4, that is 10 ohms. Okay. Now what is a current flowing through the circuit? The current is equals to, for this ideal battery, it should be equals to the EMF over R equivalent. So that should be 12 over 10, and that should be 1.2 ampere. Now just imagine if the 1.2 ampere current is flowing through the circuit. There's only one path for the flow of current. So all the current will flow through 6 ohms. And what potential difference will be measured by the voltmeter? That should, you can apply the Ohm's law. So 1.2 times 6, that should be 7.2 volt. So this is a maximum voltage reading that you will see on the screen of voltmeter. So obviously it should be from 7.2 to 12 volt, it should be. Okay, but let's prove that one as well. So now when you will make it 0 ohms, right? So don't you think you have actually short circuited at that point? Okay, so I can replace by just making a line. Okay, and this is 6 ohms. So now there's a just one resistance and there's a no internal resistance, so that's why all the voltage of the battery will come across this, and that will be 12 volts. And so that's why the option D is correct. Now the second method would be, might be, it would be the easy and new for you, because I'm going to apply the voltage domain rule. So students, you remember it's a variable resistance and we are changing it from 4 ohms to 0 ohms. Right now it is 4 ohm, and this is a fixed resistance which is 6 ohms, right? So just for a moment forget about the voltmeter, that is actually already uh, connected with the circuit. Okay, now I want to know that what part of 12 volt is shared by the 6 ohms. Okay, because according to the Ohm's law we say V is equals to IR, right? The potential difference across internal external resistance is equals to IR. Since in this is a series circuit, so I is same, that is flowing through both of them, right? So conceptually we can say the potential difference is proportional to resistance. So if among these two resistance, which one is a larger resistance, that is obviously 6 ohms. So the voltage of 12 volt will also divide proportionally, right? The larger fraction or the larger part of 12 volts will drop across the 6 ohm, and the 4 ohms will also share the rest of the voltage. Okay, so we can calculate it with the help of voltage division rule. And what it is, so let's say the voltage across 6 ohm, the rule says that in numerator write that resistance across which you want to find out the voltage, and in denominator we will add both of them, and we will multiply with the total potential value, right? So which is 6 over 10 times 12, and that is once again the same value which you calculated over here was 1.2, right? So it will be 1.2 volts right now. Sorry, that is 7.2 volts. And what is a voltage across the 4 ohm? That should be 12 minus 7.2, so that should be 4.8 volts should come across it. Okay, so you see that the voltage reading is changing from 7.2 to 12 volt when that will be short circuit. So this should be our right answer.